the two. And Jesus is going to teach me, and hopefully he's going to teach you at the same time. If you've got any questions, as you can see, we're watching the live chat, and there's a couple of colleagues of ours, Michael and Ryan, who are watching as well. So if you've got any questions, just ask them when you have them. And if you need one of us to answer it, at the Neo4j user, and then we'll pick it up and we'll answer it in person. All right, with that, let's get going.
Cool. Okay, well, I understand that probably since you're attending this meetup, probably you're familiar with at least one of the two graphs, either the RDF or the Neo4j, but still it should be a gentle introduction. So we're trying to look at the two approaches and see how are they similar, how they are different, and try to do a bit of hands-on, right? So that let's see how that works. So let's start with the slides for today. And just a bit of history, just some background on where these two models come from. So RDF is the resource description framework, and is a standard from the W3C, right? It's been around for 17, 18 years. As you can see, the first recommendation was published on 99, and it became quite popular a few years ago because it was considered the foundation of what was that vision of the semantic web that Tim Berners-Lee and well, Jim Handler and Aurel Asila published at the beginning of the century. And it was this idea of making the content on the web not only consumable by humans, but also understandable by machines in a way that it could be used in an automated way to carry out some more intelligent tasks. And of course, they define RDF as the way to present the data, to expose it so that agents, as they call it at the time, would be able to use it. And so basically, RDF is as they define it themselves is a format for data exchange, as we're going to see. So it was intended to be a way of publishing and consuming and basically exchanging data on the web. Things evolved over time, and now there's RDF stores and more users for it. But that's what was at the origin, and yeah, it was conceived as a way of exchanging data, but then storing that data as RDF became a thing, and then triple stores, as they call themselves, appeared, which were basically stores, NoSQL stores that were specialized in storing triples, which we're going to see that is the basic foundation of the RDF model. Later on, they called themselves quad stores when they included context, and you can see them also calling themselves lately things like semantic graph databases, but it's basically the same thing. Right, so that's where RDF comes from, and we're going to go into details on what the model looks like and how it's queried, how it's represented. But where does Neo4j and the label property graph come from?
So almost at the same time as this was being developed, over in Sweden, in Lund, and then in Malmö, the Neo4j folks were inventing what was originally the property graph. And so this is the one that you'll be familiar with if you've seen any of the Neo4j material on the website or in the documentation. And then I think it was late 2013, we added the idea of being able to label nodes. And so we ended up with the label property graph, or the LPG as we'll call it from now on. And the focus here was on can we come up with a way of storing data in a way that's optimized graph kind of all the way through, and come up with and be able to query that really quickly and use a model that's close to the way that people understand and reason about the world. So the way that one way that we often talk about it is the way that you would talk about a domain on a whiteboard should be very similar to what it looks like in your queries, and then again how it looks like when it's stored.
Cool, thanks. Yeah, and well, it's important to differentiate these two different origins. So RDF was more about data exchange, interoperability, and Neo4j and the label property graph was more specifically about storing and processing data as a graph in a very, very efficient way, and in a human way, as Mark was saying. So yeah, and that of course these ideas turn into what's Neo4j these days. Okay, so let's start by looking at the two models. So we're looking at these two ways of representing data because they both have something in common. It's the fact that they represent domains as graphs, right? So and of course, as you all know, a graph, it has two main components: vertices and edges, right? So it's data points connected between each other. So what do the two graphs look like? So let's look at this is not proper RDF, but it's very similar, as we're going to see. But what I want to start with is this notion of RDF is basically a sequence of statements. And they call themselves triples because it's a statement is a subject, a predicate, and an object. I have some examples here. So we have this sort of URL, I call it people, and is a person. So we have Anne is a person. That's a statement that has a subject. That would be these IDs representing Anne, and I'm saying it is a person. I have another statement that's saying that Anne has an application user ID that's @Anne. I'm saying also that Anne has a name, and the name is Anne Smith. You see that the pattern is subject, predicate, object. That's a triple, and that thing actually forms a graph. And it does it. Let's look at it. I'm going to draw it as we read it. So the first statement will represent a node, as we call it in labeled property graph terminology, representing Anne, and there is a relationship connecting it to a notion of probably a category. We'll go into more detail later on. But that's an edge. That's a connection between two nodes. And the same will happen with every single statement in this sequence, right? So we have an application user ID that's @Anne, and we have a name that's Anne Smith, and there is another resource representing another individual representing Dan, and Dan likes Anne. So you see that every statement represents an edge in the graph, and we're kind of forming a graph. So it's interesting to observe here that if we think of the graph as a collection of vertices and edges, the vertices can be either things, as Anne or Dan. Sorry, there's an error there. I forgot to fix that one. And but also the values of some properties, something that, as we're going to see in the property graph, we would consider part of the description of Anne, like her name or her user ID. They're also represented as vertices in the graph, right? So it's kind of an explosion of every single statement as a node in the graph, right? So that's what an RDF graph looks like. We're going to see it for real in a minute. But important to know, and too much text on this slide, that as you've seen, vertices can be either things or values or properties, and the edges will be always connections between these things. But not a single item in our RDF graph has any notion of internal structure. It's just a URL, if it's a unique identifier, or a piece of text, right? And that's slightly different from a property graph. So now I'm describing the same domain, but instead of describing it in terms of statements, like as we did before, Anne has that, Anne has that, I'm describing it more in terms of a description of a thing. In this case, Anne is a person. She's described by her name, that's Anne, by an application user ID. And this is what in Neo4j and in the label property graph we call a node. And a node, it's partially hidden by the camera, but a node will have a set of properties that describe, that characterize the node, and that are not necessarily part of the graph structure. So they are the internal structure of nodes. So the same semantics, the same information that we saw in the previous example would be represented in a label property graph with only two nodes, just the one representing Dan and the one representing Anne. And then there will be properties that characterize these nodes and also the relationships, as we're going to see. But the graph will be significantly more compact, right?
I think this is one of the things that people notice when they have an RDF background and they start using graphs. When they start out, they create nodes for everything. They're like, oh, I can have a node for the name, and I can have a node for the date of birth. And they pull everything out and make it, like, I suppose, really, really denormalized.
Yeah, exactly. And that's something that you could do in Neo4j. I mean, it's just not the way you would model it, because you would not be taking advantage of the capabilities of the expressiveness of the labeled property graph.
Yeah.
But yeah, that's true. That's one of the things that we see quite often.
Okay, so to summarize so far, what we've done so far is we can model. We had a set of RDF statements, and we've seen that we can model that as a graph. So would you say they're equivalent to each other?
I think they're semantically equivalent. So it's exactly the same set of same information. I mean, one is described in terms of individual statements, and the other one is described more in terms of things. So there's a thing that can have properties, and then they're connected, so that Dan like Zan becomes a relationship.
Yeah.
But it's exactly the same information, and we're going to see that it can be queried very much in the same way, but according to different models.
And how does the URI thing work? So on some of our there were parts of the triple we had URIs, and some of them we didn't. I know a little bit of it was to make the example simpler. So would you what would it be if it was a real example?
We're going to see that in some examples in a minute, but that's one of the central points of RDF. So RDF is based on the idea of identifying things uniquely and make it in an explicit way. So it's true that when we store or we create a node in Neo will probably give it an internal ID that we can use or we can query, but it's not something that's domain oriented. That's part of our modeling. Whereas in RDF, you make explicit how you name things, and you do that by using URIs. And you will, every single node, they call it resource, will be identified by a URI, and the same for relationships. So any predicate in a statement will also be a URI, and a URI is the syntax of a URI is a unique identifier.
So each of the things in the triple is called the resource.
The resource will be the subject or the object. So anything that represents an entity, so it will be the equivalent of a node in Neo4j, is a resource. If it's the value of a property, then they call it a literal. So it wouldn't be a resource.
Okay, cool.
Okay, that's a great point, because actually it's interesting because in RDF they call properties to relationships. So there might be a clash of terminology, and it might be a bit not super intuitive for people who come from RDF. So that's great questions. Cool.
Okay, we don't have any questions so far, so I'm assuming we're good so far. If you have any, shout them out on the chat. Otherwise, that's our introduction, comparing the two against each other. So we can maybe we'll move on to the next section.
Good. Right. So just to do the analogy with the previous one. So vertices in the label property graph are just the nodes, and the edges are explicit relationships, and they will have a set of key value pairs that can characterize them, that can add a description of them. So essentially, they have internal structure. So there's information that's not part of the graph structure, but the internal structure of nodes. So that would be kind of the conclusion of the previous section. So let's look at an example. So we've used just this description in kind of something similar to English, but now we're going to look at really at a fragment of RDF and at a fragment of label property graph using Cypher. So we're going to use this example from Google's knowledge graph. So if you've done a search in Google, you see that sometimes if the search identifies a concept, it can be an album like this one, a music album, but if it's a person, if it's a football player, a musician, a location, a city, anything, well, Google will bring these sort of snippets to the right-hand side of your search, and it's kind of a structured representation of the thing you were looking for, right? So if you do a search for sketches of Spain, this album by Miles Davis will turn up, and you see that there's some information about some structural information about it, like a description of it, who's the artist, what's the release date, the genre, the producer, and some awards about it. So it's this small fragment, this small piece of information.
And so this is like part of the. I've heard people talk about this is the Google knowledge graph. This is like part of it. Like
exactly. So that's what we see, because the thing is, it's not public. It's something they talk about. If you Google it, that you can see that there's some structural information internally, and they try to map your text search into something that's more of a concept, a structure thing. But what's a bit frustrating is that you can't query it directly. So you do your search in Google, and it will come up with that. Yeah. There's an API where you can do, again, basic string searches, but you can't query it in a structure where you can't run Sparkle queries against it. So what we're going to do is just take a small fragment of it that I generated, but you can't really query it, unfortunately. So. What would that data look like in RDF? And now that's proper RDF. So it's not, as you see, it's exactly the same we were looking at before. So it's a sequence of statements. So it's subject, predicate, object. The thing is now it's proper URIs, and proper property names. So
what's schema.org on these examples? Is that?
Well, yeah, schema.org is a vocabulary, right? So if you see here, the first statement, we're talking about this resource. This resource is the unique identifier in the knowledge graph of this album by Miles Davis. So we're going to be saying many things about it. So that's why it's the subject of many statements. So the first thing we say about it is that it has a name, and the name is Sketches of Spain. Now the name, again, you want to not say the name of this album is that, is name according to that particular vocabulary. So it's kind of a way of being specific. And again, it's this idea of a URI, of being specific about what you're stating about that album. So that's why, in the same way you need to identify the album uniquely, you will identify the property, or the relationship in this case, that you're stating about it. So you're saying that the name of this resource is Sketches of Spain.
And so if you went to that URI, was that actually a valid to be able to see something?
I mean, that's a very good point. I mean, not necessarily, but the linked data community is based on the idea that any resource that's part of your data you should be able to dereference it. So there should be something on the web that at least describes what that is. And I believe with the schema.org, which is one of the most widely used vocabularies, and that's the one that's used in the knowledge graph, that's the case. So if you put that there, you will get a description of what name is and how it relates to other elements in that vocabulary. So that would be closer to the notion of an ontology, although I think today we're not going to have time to talk about the semantic side of things. But yeah, it's a way of being specific and uniquely naming the property that we're assigning a value to. So in the same way we give it a name, we're going to say that the type of this is a music album. Then we say that the description is an album by Miles Davis. It has a genre, and then it's connected to a description. And then here we're using something that's a bit obscure thing, which is this notion of blank notes in RDF, which are things that are part of the structure, but you don't want to give a unique name because it's like transient elements or not necessarily uniquely identifiable. So it's just, in this case, this object represents kind of a container representing the license, the URL, and the body of this detailed description. So it's a structure, and you want to bundle these three things: the license, the URL, and the body. But you don't want to give that necessarily a URI that's unique. So I mean, that's the referenceable. And
then, and I think as you said at the beginning, if we took this, we could choose to paste it into like a console.
Good point. So let's do that. So it would be a good time now to introduce the bit hands-on side of things. So I'm going to be working on Object in order to be able to run the property graph queries, but I'm going to be using also a triple store so that we can compare and see the things side by side. So the triple store that I'm going to be using is RDF4j, even though the similarity on the name has nothing to do with Neo4j. It's just the old Sesame API, library, and it's quite popular. It's being used by many triple stores, commercial triple stores. So it's a simple interface that will make it possible for me to write some RDF and query some RDF. So yeah, so I'm going to use for this a guide that you can use and run. So if you probably want to
so I've put that into the chat. If you've got Neo4j running on your machine, then you can follow along, and you just type the command that I've pasted into the chat. So if we go over this one? So this is so we've got a different one here, haven't we? This is
hang on. The problem is that I'm on page 7.
Sorry.
So that's what page 1 looks like. Sorry.
So this is on the right. So at the top we've got the RDF.
So that's the RDF that we were seeing. So it's a description about the album. So what I'm going to do is I'm going to grab this. I mean, I'm not doing anything fancy here. So as you see, it's a sequence of triples. It's a list of triples. And when I load that into my triple store, my Sparkle update interface, that from a previous execution. So if I paste my RDF here, not super excited, it's just an insert statement. So I'm saying insert this sequence, this list of triples. And when I do that, minimize that, this will populate my graph with 20 triples. Especially Neo users, you would expect something visual, something nice, but well, at times, no, that's not the case. All we can see is a list of triples.
So this would be if you wanted to export it, would it?
Exactly. That's just a listing of all the triples that I've just created, and I'm going to be querying them in a minute. But that's the same set of information that I'm going to load now into Neo4j. So let's keep that for a minute. So we have a triple store loaded with this list of triples about this album by Miles Davis.
And so every line we had in our text is one row on this table.
It's a row if you want, but it's like
Okay.
I mean it's a statement, I would say. But yeah, it's a row with
Okay, so
analogy with relational.
Cool.
And now we're going to do exactly the same, but in a cipher. So if you're familiar with it, that's what it looks like. So here,
so shall I? Maybe I'll just
sure.
quickly go over the cipher for anybody who's seeing it for the first time. So it's quite similar to what we have in the RDF statements. So the top statement is we're saying I want to create something. What do I want to create? The thing to the right of the create statement. So that's saying I want to create. I'll just highlight it so you can see. So I'm going to create this, and the two parentheses represent the fact that I'm creating a node, and then inside that the brackets we've got some metadata. So from the left-hand side, SOS is just a variable name, so that's just so we can refer to it later on. We're then putting a label on, so that's music album. So that's indicating what type of node we've got. Like we're putting like a tag on it, if you like. I can make this a bit bigger. Maybe it's not completely visible. Hopefully that's better. We've then got, after that, inside the curly brackets, we've got a set of what we call it properties in Neo4j. So we've got a name, and then it's got the name of the album, description, and genre. And then if we scroll down, we do the same for the next. So this was the one this was the anonymous node, wasn't it?
Yeah, exactly. But we call it a detailed description. I mean, in Neo, there's no difference of what. I mean, the thing is, Neo is more about your local model. It's not about exchanging and naming things in a unique way. Okay. So here, for us, it's just a node. It's another node representing a detailed description that will contain a license, the body of the article, and I think. Okay, so that's like it's got so it's got a link to the license, and then we've got some text. Yeah. About it. Okay, so that's cool. So we've got two nodes at the moment. Just checking out. I think hopefully it's big enough. We'll try and go a bit more slowly while we're moving between it. Should we get rid of the bar? Okay, maybe that's a bit better. Okay, so we've got two nodes at the moment, and one was called SOS and the other one was called DD. Now we're going to create a relationship between them. So that's what we're doing with the Goog_detailed descriptions. That creates like a Google description, detailed description for the Sketches of Spain node. Yeah, and then if we scroll down to the next line, then we're creating another relationship for the awards. This has won a Grammy Hall of Fame. What we're doing there is we're at the same time, I mean, we're creating the award, but at the same time we're linking it to the Sketches of Spain album. So we're doing the same line because it's compactly. You can create the node and link it to the album, and similar with the. And then we've got some people who are involved with the album. And I guess the nice thing here is that we can, or maybe it's the same with RDF. We can say what specific relationship do they have. Well, the interesting thing is here it's not as we can see here before a list of statements. I mean, we're talking about objects more. It's like here we're clearly describing an album, and we're giving the properties about it. So we're creating a thing, and then we're going to now link that to these other element, which is the description or the author or the producer. So it's kind of a different paradigm. It's a different way of describing things. Semantically, it's exactly the same. So the two models contain exactly the same information. Yeah. It's just a different way of modeling it. And when we run this, I mean, the interesting thing, I'm going to run this here in the browser. See that there's a number of elements have been created. Now we can look what's in our graph, and we see that it's a pretty compact graph. So we have at the center our album, right? And it's connected to a number of entities. One will be the award, the we might need to zoom that in a bit to make it a. I guess we can. Oh, there we go. So that's a bit bigger. So what have we got? So we've got in the blue. So that's the album. So that's the Sketches of Spain. That's what showed up on our Google Knowledge graph as the main entity. And then what else have we got? And you see that it has a set of properties. So some of the information has been modeled as properties. We can see here at the bottom. So we can see the name, the genre, the description, and then we have a number of things around it. So things like persons representing, actually we could present these in a different color, so we can make yellow the persons, and we see that there's 3 individuals. One is the artist, one is the producer, and another producer.
Yep.
And we have an award, and so on and so forth. But it's a pretty simple and nice graph. Now, let's quickly go back, and before we start querying this to the slides, because unfortunately, as I said, there's not a visual representation on the triple store, but that's what the graph looks like if we think of the triples that we've just created. And as you can see, if you compare this with the Neo4j graph, it's structurally very different. I mean, the information is the same, yeah, but here we're creating a lot of nodes. Every single value of a property will represent a node in our graph. And that's, well, if you count it, it's 20 something nodes, whereas in our Neo4j one, in our property graph one, we have like, what, 5 of them. And that's the nature of RDF. So RDF is based on this atomic decomposition of your data, and each statement will create an edge in your graph. So different ways of modeling.
And so we would use an external tool to generate this diagram?
Well,
how would you do it?
I guess, well, that's a very good question. I mean, the thing is, this kind of graph, I think, is much less intuitive and much less easy to consume or explore in a visual way. Okay. So that's probably why, I mean, that's probably a question to answer by RDF triple store vendors. Okay. But in general, I mean, I don't think there's a great deal of tools to visualize RDF data. But
so would you could say it's quite unusual for someone to do it, or they would want to do it, but it's difficult to do?
In my experience, I mean, and we're going to see some of the problems and limitations in terms of modeling expressivity. It's harder to explore because it's much bigger. It's an explosion of information to explore. I mean, if you think of our graph in Neo4j, it's close. It is an idea of intuitiveness that we mentioned before. Yeah. I mean, if we think of what we're talking about an album that's created by an author. I mean, this is very close to what I would put on a whiteboard. Yeah,
and if we were just having a chat about the album,
we put that in front of anyone, and you quickly get it, because it's represented around this notion of entities. Whereas this, even though it's exactly the same information, well, it's probably harder to follow. I mean, yeah, you see that the album is this thing, and it has a property that's here. That's the description of the album, and there's a person that has. I mean, but I think it lets itself less to visual exploration. Mm-hmm. But well, that's the two models.
That's interesting though, because one of the I don't know whether it's the same as your experience, but my experience with people when they first come across graphs, one of the things that really strikes them as really interesting is, I can visually explore this, and they'll load up they'll put some data in the Neo4j browser, and they'll be like, oh, once I click on there, and they'll have a look at what other things are related to.
And that's
quite an interesting
distinction. It's a good one, and I would like to hear people's feedback on that. How RDF users, if they use it in a exploratory way, what sort of tools they use, and how. If they maybe build a logical layer on top of this, because there may be some elements that you don't want to present as triples. You want to present a higher level view. I don't know. That's something I'd like to hear from people.
Cool.
So
all right, should we move on to our
quickly?
Well,
that's what we've just run, and that's the graph that is produced. And just a quick note on precisely on that. On when people hear about this graph, that this RDF graph contains a million triples or 100,000 triples. Well, keep in mind this difference. I mean, when we talk about triples, it's not equivalent to the notion of nodes in the property graph as we've seen, because this is a simple example that we have on the screen here. But think of a graph, of a property graph, and a reasonable number of properties per node might be 5, it could be 3, but there will be a number of properties. There will be a number of relationships which could have properties themselves, and we'll have labels that represent categories. So in a simple, modest model like this one, you would have 11 times triples, 11 times as many triples as the number of nodes. So in general, if you compare them, there's typically an order of magnitude difference. And we've seen the example here. So this is 5-6 nodes, whereas this one here is probably 20. So it's a simple example, but you quickly get the idea. So it's when you compare these numbers, keep in mind that a triple is not a node, right? A triple is a single statement, it's an atomic value. That could be a property, or could be just a bit of a property graph.
So we've got a question, I guess, before we go on to the next bit. So question is, can you write Sparkle queries to match patterns in addition to Cypher out of the box? I guess the question is, can you run Sparkle on Neo4j?
Well, the answer is not directly, and that comes perfectly in time because we're going to just now talk about the query language. So you go with RDF, and the query language for RDF is Sparkle, right? You go with the property graph, and the query language for the property graph is Cypher, right? Okay. So it's different paradigms as we've seen, and they have different query languages. So I believe there was a community effort a few years ago to build an extension to Neo, but it will be based on translation. And I'm not saying it could not be done, but if you model data as a property graph, you want to query it with Cypher, right? And in a similar way, if you have RDF, you will want to query it with Sparkle. So
okay, let's have a look at the two of them then.
Right. So very briefly, because we don't have time, or it's not the objective of today's session to have a proper training on each of the languages. But okay. So that's the graph that we were looking at a minute ago. So and what you have on the right-hand side is a query. So this query returns the names of the artists that have had an album produced by Irving Townsend, right? So, and let's go to the guide, because we're going to run this query against the property graph that we've just created. So I might have saved it. If not, I can copy it quickly. No, it's not here. Not a problem. So we can go to query and get the query from the guide. So our guide should be somewhere here. Let's go to the next page. So this is our query. So we want to get which are let's copy it here. So let's look at the query. So it's based on triple patterns. So what we've done is, instead of providing triples as we did before, what we're doing now is in triples replacing elements with variables. So we're saying, well, look for a triple that has the property name and the value Irving Townsend, and that will be a producer. So is this producer connected to something through the producer relationship? Well, that will be an album. Well, that album will also have an artist. So the artist will have a name. So as you see, I'm jumping, following statements, throwing triples, and what this query will return is the artist name, and that hopefully should be Miles Davis, as we see. The nicest presentation, but that's the idea. So that's what Sparkle is based on. So it's, again, triple patterns. It's a graph query language, but it's, in answering this question again, it's very, very triple oriented.
So we're focusing on like statements. We're trying to find like the we're trying to find. Would you say we're trying to find the matching statement for the query?
Yeah, exactly. So I mean, by combining statements, what you're doing is defining a graph pattern, but you're describing it in terms of individual statements.
Okay.
Right. So there's no difference when you're querying a statement with a property value, or a statement that connects to relate to individuals. For example, an album and an artist, and that's what's equivalent looks like. So that's exactly the same semantics. So we're looking for the artists that have had an album produced by Irving Townsend.
So should we just quickly go through? I'll quickly go through the syntax on this one. So if we start from the top left-hand side, if we're querying a graph, we need to start with the match keyword. So one way to think of it is we're matching a pattern. And what is the pattern? The pattern is a combination of, well, it could be nodes, relationships. It could be more nodes. In this case, we're saying I've got a node, which I'm going to give a variable name prod, and that needs to have a relationship called producer. That then goes to another node in the middle, which we've named album. That's just, again, a variable name. Whatever that node is, it needs to have a relationship called by artist out to another node, which this one we've named artist. And then we're putting a constraint on the query by saying, well, that first node that you looked at, make sure that it matches the name property. So make sure the producer is Irving Townsend. So in English, find me, find Irving Townsend, find the albums produced by them, and then find the artists who featured on the album. So it reads, like you just read. You can read it reasonably well. Drawing
there, I mean, you see here three nodes: a producer, an album, and an artist, and they're connected through this producer and artist relationship. And then you're applying filters on certain nodes. So that's what you're doing. And if you run this query, well, that would return you obviously the same information. That's Miles Davis, right?
That's good. We've got an
equivalent
query.
Semantically equivalent, so same expressivity on both, but represented in slightly different ways. And well, it will be up to you to decide which is more intuitive or more suited to your likes. So we've looked at querying, but we will want to update, and we will want to modify values. Again, we're going to see that later on. But in Neo4j, I mean, and the label property graph typically is a store that you would use in very dynamic environments. So it's made to take changes and be modified, very frequently. So updates are crucial, and that's not so much the case in RDF. And typically RDF models are used more in like incremental or very slow changes, like knowledge-based style graphs, like the one we saw before. Actually, just it might be interesting to come back to the slides, and we'll see that actually Sparkle only added updates to the graph, what, 2 years ago, 3 years ago. So it's been quite a recent addition, because it's not the natural way in which you would use a triple store. But let's look at a simple example of how you can modify, and a simple modification is how you uppercase the values of a property. Right, to the left-hand side, you have the cipher variant of it. So we're going to look at that in the triple store and the Neo4j. So let's do it first in Neo4j, since we're here. Next page, no, that's here. So what are we doing here? So we're taking
so again, remember, we're doing the match clause. So saying I want to find a pattern. Which pattern is it this time? This time we want to find any node that has a producer relationship coming into it. So that would indicate that we've got a producer in the P variable. Once we've got it, we can then go down to the next line, and we're using a keyword called set, which we use to put properties on nodes or relationships, in this case on a node. And we're putting the property name, and we're just uppercasing it. So we're actually reusing the same property and just calling a function called toUpper.
Exactly. So whatever the value is, just uppercase it. And if we run this, that would we can see that if we go to the person nodes, I mean, we can see that now they're all uppercase.
Except for Miles Davis. I guess Miles Davis
he's not producer. That's the thing.
Anything.
So he's if we expand these nodes, we see that the producers of this album are these two.
Yeah.
But Miles Davis is the artist.
It's an artist.
So that's right. So it's correct. So what would that look like in RDF? So let's grab the code from the guide.
I think we can probably just look at the RDF examples. Otherwise, it's going to take a bit long. But yeah, let's go over.
Yeah. Again, as you see, it's way more complicated if you want. So there's a where section on your query where you identify which elements you want to update. So that would be equivalent to the pattern we've used. So we're looking for something that's connected through the producer relationship. And then for this something that we alias as prod, we're going to get the name, right, which is in the property segment. And the way to get it is we need to associate that, use this binding. So we want to get this value, right, and uppercase it and associate that to a new variable that I call new value. So here is just the matching part, and here is the update. I mean, you have to read it from the bottom up. So what you want to do is you want to delete the old value or the property name in prod, which is the producer that we had, and we assign the new value. Okay, so
we're deleting one statement, or we put in a new one.
Exactly. Because what we're doing is we're replacing the old one. We'll see that we can have multiple values, but that will come in a minute. Right. So that's the very quick overview of what querying and updating looks like in both Cypher and Sparkle. Right. Let's move on to the next section, and here we're going to look in more detail what are the actual expressivity difference. What things can you do and can you not do in an easy way with both paradigms. So the first one is RDF. So it does not uniquely identify relationships. So relationships are what in the label property graph we would call the type. So, and the implications of that is that you can't have two instances of the same relationship between two given nodes, right? And we can see that in an example. I don't know if it makes sense to run it. I mean, all these queries are in the guide, so maybe it's a good idea to leave that to them, because otherwise it's going to be longer. So what happens if we try to do something like this in RDF? So we want to say that there's a node representing Dan and Anne, as we saw before, and Dan has liked Anne 3 times, right?
Yeah.
And take this like as follow, love, whatever you do in social networks, right? So something, for example, like that. So if we state that 3 times, actually, these three statements are identical. So we're actually stating exactly the same information. So the fact that I'm doing it 3 times is irrelevant. So, and that can be seen by running this query. If I run this query here, well, I get that the count, and of course, we haven't seen the details, but what we're doing here is matching what are the connections between Dan and Anne and counting how many likes. So that's a count, is an aggregate query in Sparkle, and it returns 1. So it's telling me he's only liked her once, and the graph has only 1 link because the predicate is what we call the type. So there's no unique identifier of every time the nodes are connected, every instance of the relationship, right?
So it's just the SC:likes is unique in this example.
Exactly, it's unique,
okay.
but it's not. I mean, if then Dan liked also William, right, we would use exactly the same likes.
Okay.
So that's the type of the relationship, but it's not this individual instance of the relationship between them.
Right.
So we're gonna.
So is it the whole statement that makes it unique?
Yeah, exactly. A statement would be.
Okay. So when it goes through, it probably creates the first row, and then the second one, it's like, oh, well, I've done that already, so there's nothing to do.
Exactly. It will, or it will even overwrite it, but it's the same piece of information. Whereas in Neo4j and in the label property graph, each instance of a relationship is unique, right? So we can say that Dan likes Anne, and then he likes her again and again. And if we now count, that would be the equivalent syntax in Cypher, we will get 3 instances. And that's because even though a relationship has a type, they are internally unique, so they will have their own unique identifier, right? So that might not sound very, very important because probably you won't model things like that, but that takes us to the second difference, which is since you can't identify them uniquely, you can't qualify them. And by qualifying, I mean I've added this definition is adding a description to it. I can't add attributes to it. So let's look at an example. So we want to model the connection between New York and San Francisco and add attributes to it, properties, right? We want to say that there's a connection between these 2 cities. Maybe there's multiple connections, right? But one of them is through flying, and it takes this number of kilometers and has this cost. Maybe there's another connection through another means of transport, but you want to have the same type of relationship between the 2 and add attributes to it. You can do that in the label property graph because each instance of the relationship is unique. So you can say, right, these pair of attributes are for this specific relationship, right? And we can query it, right? So we would represent this with Cypher like that. We would create the relationship, and then we can query it and get the attributes of that relationship, right?
Yep.
Now, if you try to do the same thing in RDF, and you can try that with the query. The queries are in the guide. I mean, how would you do that? I mean, you say there's New York City, has name NWC, San Francisco, and there's a connection between them. And then what do? You say, and connection has a distance, but then connection is generic. So if then you have the connection between New York and Las Vegas, I mean, these would be ambiguous because that would apply to any of them. And that's precisely because of that, because you can only use one thing. You can use only one URI. So if you use it for the type of the relationship, then you can't use it to uniquely identify them. So
we have a question from the chat,
right.
Which is about how do you handle namespace collisions in the label property graph model. So in the RDF, it was just by the combination of the predicate and the name and the.
Well, the thing is, in RDF you have the notion of URI, which is which can use namespaces and can basically by prefixing. I mean, what you do is you prefix things with a unique URL, and that way you have unique names. I mean, in Neo4j, since Neo4j is a database, so you're kind of the owner of your data set. So it's up to you to define unique identifiers for relationships, for types, for categories. Now, when it's about exchanging and publishing your data, then you might want to take into account the fact that there might be clashes and you want to be unique. And that probably we won't cover today, but you can publish, you can expose data as RDF from Neo4j, but it's not a thing. I mean, you have full control on your model in Neo4j.
Yeah, so I think in our example, the use of the likes there basically was describing the same thing. But a reasonable way that it might be different, like if we were trying to uniquely identify that like would be, I think would be like, say you like the person and then you might choose to not like them and then you like them again. So maybe we store some properties on there. So we say, okay, well, I started liking the person at this date and then I stopped at this date, but then I started again at another date.
Exactly.
Then it could be maybe the start and the end dates are actually how we uniquely identify it in the label property.
Yeah, that
so
would make
the combination of the relationship name and the property.
Although I think what he means as well is when, for example, I mean, in the Google property, the Google Knowledge Graph is an example. Typically, triple stores will integrate data from many different sources. So let's say you're bringing data from the Wikipedia, from your own store, and you have a names relationship in both. You have a column, and you need to be able to tell where does it come from. So if you bring it in the same graph, you need to be able to tell, well, that's names, but names according to the Wikipedia, and that's names, but names according to my local database. Okay, so you would use a different namespace and different URI for the likes. In Neo4j, you would probably use you can use some prefixing. I mean, you can. It's a modeling decision how you. But there's not the notion of a namespace, right? So very quickly. So
we've probably got about 10 minutes left, haven't we?
Right. So yeah, I think we
maybe speed up a bit.
Yes. Yeah. Well, actually, probably not go as far as I was planning, and because. So how would you then because you still want to model the reality that there is a connection between New York and San Francisco that takes this amount of money or this time. So how will you do that? Well, there's a number of ways in which you can. It's not that you can't model it in RDF. Of course you can, but you will have to find alternatives, right? And one of them is a modeling workaround. So you can look for you can create an intermediate node. So in order to do something like that to the left, that's the natural way of modeling it in a label property graph. What you would do in RDF is create an intermediate node. So because you can only associate properties to a node, what you would do is say, well, I'm going to create something that represents the connection between New York City and San Francisco, and then that thing can have properties, and I can give it a distance in kilometers or the cost in dollars or whatever. So that's a modeling workaround. So the problem with this is that we're kind of artificially introducing something that we may not need to model just because the paradigm imposes it, and that's, for example, what happens with in relational with the many-to-many relationship.
The join table.
Exactly. So you don't really need that. It's because it's the only way to represent that in the relational model, right? So you can't only say that this relationship is many-to-many using just foreign keys. You need a join table. So in this case, RDF is forcing you to create this artificial node in the middle to be able to then give it the properties, right? So.
We did actually have a question whether you introduce an intermediate node to handle these properties, and you've answered it.
Of course. On the next slide. I would say that's the typical way, because the other two that I've just mentioned here are just probably for really hardcore RDF people. So I've added the reference, but the one is called reification, and it's defined in the RDF spec, and it's basically about overlaying a meta model on top of your model. If you look at here on the right hand side, we have the Dan likes Anne. But you want to add a meta model on top of it to be able to say that it does it 3 times. So you're complicating horribly your model in order to be able to accommodate that. So there's a reference if you're interested in that. And similarly, that's and the way to query it becomes crazy difficult and hard to maintain. So I doubt that that's something that people are actually using and updating as well. I'm not going to go into the details. Feel free to look at this Sparkle.
Yeah, I think I tried to have a read of this beforehand, and I was a bit
and this one
over my head.
Is even similar. I mean, here what they're doing in a way is this idea of let's not call the relationship Dan likes Anne. Let's give it a unique identifier. Okay. So that's kind of closer to the property graph, to the label property graph. But then you have to say that that's actually a likes, because if you don't tell me that that's likes, how the hell would I understand that 1, 2, 3, 4 means likes? So you have to create another meta graph here and saying the type of these is actually likes. And it's happened 3 times. So you're kind of overlaying another model and overcomplicating it. There's a description, there's a paper that describes it. And interestingly, some RDF vendors are using this approach to model label property graph behavior on top of RDF, because otherwise you wouldn't be able to do it.
That's interesting.
But again, it's quite tricky. Feel free to have a look. And another difference, and let's try to stick to the time. So multi-valued properties. So in RDF, if you think of statements, it's very natural to have multiple values for a property, because it's just 2 separate statements, 2 separate triples. In the property graph, you would use an array, because you can have an internal structure of a node, you can have a property, and a property can have either atomic values or arrays of values. So that's the way you would model. You have an example here. Back to our Miles Davis.
Okay, so this is similar to what we did before. We've just added the genre in, and the way we've chosen to model it here is as an array, and we're just putting 2 types of jazz in as the values for the genre. And I suppose you could argue that this is one way of modeling it. As if you wanted to search through the genres, perhaps you would even have those as another node. But,
exactly.
But if you want to have the array, then you can
exactly.
do that as well,
So
which is cool.
Yeah, and again, if you look at the graph on the left-hand side, the RDF one, you just have two values, which is a natural thing. So two different triples.
Okay, so that's more like the array of five, like bringing in the
exactly.
node.
That's
okay. That's the only way you can do it.
That's the only way you can do it in RDF. Yeah.
So you get the choice in the property graph.
Exactly.
Okay.
So you have, because the notion of array, I mean, well, again, there's again a list in RDF, but it's go to the spec because it's a horrible thing. I don't think no one uses the lists. That would be another way of modeling it, but I don't think it would be super efficient. Good. So, and finally, the last of the difference that I've identified and that I wanted to cover today is in RDF, there's since every statement is a triple, it's very easy to add an extra piece of information and defining subsets of triples. So you can tag a triple with what's called a named graph. So you can say this triple is in this graph, this triple is in this other graph, and by doing that, what you're doing is defining subgraphs, defining named graphs, which is quite a useful thing that you can't do at the moment in property graph. And I say for now because that's something that's being studied, and we hope to be things happening in that space soon. So that's an interesting feature in RDF that you currently don't have available in the property graph. Good. So maybe, given the time that we've spent here, it might be a reasonable, because the next thing I was going to look at was integration. So how do you, we've seen how they're different, how they're similar, how they can be queried, how you can model things. The next thing is for example, how you publish data from Neo4j as RDF, and how you bring RDF data from your triple store into Neo. But I think that probably will make a good. Okay,
well we've got a question for us that we can probably answer now.
Yeah.
So the question is, we've talked about lots of advantages of the label property graph because we've been contrasting and often pointing out, it looks a bit nicer in the property graph. What context would you say it's the other way around, and you quite like what is there in RDF and that world?
Well, if it's about liking it, it will depend on each one. I mean, if you maybe some people like the simplicity of a statement and that it's a very basic and I was going to say intuitive. I wouldn't say that, but I don't know if I think probably RDF is closer to a logical modeling of domains. So like in terms of statements. Then, of course, we haven't talked about it, but there's a whole stack on top of RDF, which is, RDFS, OWL, and there's the possibility of expressing semantics, which are for rules that make it possible for you to infer new information. But again, that's something that you can also do in the property graph. So, I mean, to me, I would say that it's more humane, it's more natural to do it in the label property graph. It's easier, and my experience is that people just get it. But again, I mean, it's something. Is it about what you like? I mean, it's not a question that I can answer. I mean,
okay, next one. Well, actually, maybe another question then. So I guess you came from a very RDF background and done a lot of stuff there, and I think you found it quite easy to pick up the property graph model. Have you found that other people with that background have the same experience, or are there some people who are like, I really like it?
I mean, I had spent many years with RDF, and there were things that I just didn't get. For example, this idea of every instance of a relationship is unique, so you can have 3 times the same relationship. I just didn't. I mean, it was just different. It took me a while, but I think the learning curve for to get the property graph is much it's much easier. I mean, and we're seeing it. I mean, how people just download Neo and can model a simple domain. RDF, for some reason, I mean, it's probably more complicated. It's less intuitive, and my experience is that only people who have spent a while and a bit of time and put the effort on it get to the point where they get it and where they see the power of it. But that's my experience. I think it's less intuitive. That's my experience.
Then our next question is, can you comment on the performance of the two? Right. I suppose this is going to be a very subjective.
Well, exactly. And the problem is today we've been talking about more, the expressivity of the models. What can you do and what can you not do with the models? But then we have to look at it from the point of view of the stores. So we haven't talked about, behind the label property graph, there's Neo4j. Behind the RDF, there's a number of vendors. So I can't say RDF in general is performant, it's not performant. I mean, I will have to take a platform. I mean, let's take, for example, I mean, onto text. I mean, Mark Logic, Stardog. I mean, you have to take a platform and then compare them. So I don't think we are planning to do any kind of workbench on this, but that's a completely different dimension. I mean, looking at the performance of the store is different, and we can talk about that because it's different. I mean, the native storage in Neo4j is very, very different from the very index-based storage of triple store.
I mean, that could probably be a whole talk. And
I think that we'll talk more about it, but today we focused on the expressivity and not on the performance, which would be dependent on the underlying engine.
So one thing Michael's pointed out in the chat is that if you look at how people share data, a lot of the time they do share it in an RDF format. So I think we looked at the knowledge graph, and then there's also the Bloomberg, and I think the BBC have
Reuters have a Reuters have a there's a whole bunch of public data sets, and probably hang on, I'm going to go to the conclusions. I'm going to skip through many of these, but
so we can post these slides. Maybe
we will, sure.
But
what I want to say is that that's true. I mean, the important thing is that the two are graph based, so they both model reality as a graph. The way I see it is that RDF is more like an exchange format, exactly like what Michael said. So it's a way of exchanging data, of presenting your data, regardless of how you store it, right? Whereas Neo is all about storing and accessing data and updating data in a very efficient way. So we will see that you can publish your data as RDF because RDF is exchange format, and still store it as a property graph, and take advantage of Cypher and all the intuitiveness and benefits of the property graph. So they're not incompatible. So it's still absolutely possible to be open standards and RDF compliant and publish information in a way that RDF compliant applications or consumers can use it. And we'll talk about that in probably future episodes of this meetup.
Okay. And then we've got there's another question about Neo4j Java jar. So I'll just quickly answer that one. So we're about 1 minute from the end. So if you explain a bit more what you want us to talk about, then perhaps we can arrange our next live stream and focus a bit more on what you're after. Otherwise, we're happy to wrap up.
We're happy to wrap up. I mean, just a link to the blog where I publish some of these things that I do, but probably we'll come back on Meetup more on the interaction on how. I mean, I'm happy that we've covered the difference between the two models, but there's a lot to say about how they can integrate, how we can bring data into the graph from RDF and the other way around. So I think that's good for today.
I just wanted to do just quickly before we wrap up. I'll just point people to the next event. I want to tune in 2 weeks' time. So I'll just wait. Hang on a minute.
That's the London one.
That's the London one.
That will be.
So it will be Neo4j. Hang on, maybe I'll Google it. Might be quicker. There we go. So next one is in 2 weeks' time. Same time, same day, and this time we're going to have Johannes from Mesosphere is going to be presenting Neo4j running on Mesos and DCOS. So if you're interested in that, obviously make sure that you register. And we've now created an online meetup page, so you can go and look at the previous ones on there. And finally, just a shameless plug: if you like this content, be sure to like it on the YouTube video, and we can create some more stuff for you. And on the chat, let us know what you want to see next, and we'll try and do that. But thanks everyone for joining, and sorry for those of you who just got here with 2 minutes remaining. But you can always watch the video afterwards.
And you have the guides available, so feel free to play with them. And
and thanks to
see you soon. Thank you. It was great.
Thanks everyone. Bye.